Now we're going to factor what we call special products. The first special type of factoring that we have is called the difference of squares. A polynomial is a difference of two squares if there are two terms, one of them subtracted from the other, and both terms are perfect squares. Just as a reminder, here's a list of the perfect squares up to 15 squared, which is 225. Again, these are things that are going to be very helpful if you just know them right off the bat. In number 1, I have x squared minus 9. X squared is a perfect square because x times x is x squared, and 9 is a perfect square. 3 times 3 is 9. So we're going to use this form to factor our difference of squares. So the original form is a squared minus b squared. I'm going to take the square root of each term, and those are going to be my two factors, where one of the factors has plus inside and one of them has a minus on the inside. So for number 1, I'm going to do x plus 3, take the square root of both terms, and x minus 3, and those are our two factors. If you're not sure, you can always redistribute and see if you get back to x squared minus 9. In this one, I have 9 minus x squared. The roles are reversed here. So again, I'm taking the square root of each number and I'm keeping it in order because I need that subtraction sign to be in the middle of my two monomials. The square root of 9 is 3, the square root of x squared is x. So here my factors are 3 plus x and 3 minus x. As usual, it doesn't matter which order you put your factors in. You could have said x minus 3 and x plus 3 and it doesn't make a difference. Let's look at some more. I've got negative 162 plus 2x squared. 162 is not a perfect square. 2 isn't even a perfect square. So I need to take out the GCF first and then see what's left over. So if I want to keep everything in the same order, I'm going to take out a negative 2. So now I have negative 2 on the outside. Negative 162 divided by negative 2 is positive 81, and then minus x squared. Now this looks very much like the form that we want it to be in to use difference of squares. Keeping that negative 2 on the outside, the square root of 81 is 9, the square root of x squared is x, so I have 9 plus x, and 9 minus x. In number 3, we have x squared plus 25. Now this looks good at the beginning, right? We have a perfect square, x squared, and another perfect square, 25. But this one has an issue. It's got a plus sign in the middle. Our difference of squares has to be just that, a difference. It has to be subtraction. So with this one, we can't factor it anymore, so this one is prime. Here we have x to the 4th minus 100 y to the 6th. All of these are perfect squares as well. I know 100 is a perfect square, and any variable with an even exponent, since it's divisible by 2, those are also perfect squares. The square root of x to the 4th is x squared. The square root of y to the 6th is y cubed. So I'm going to be using these as well as 10 in my factored form. So we've got x squared plus 10y cubed and x squared minus 10y cubed. And there's our factored form.